Hi guys, welcome to my page. Here we had started the chapter number 7, lenses, and regarding this chapter number 7 we had posted the 3 videos and its link will be given in the description. So if you are new to our page, you can access those videos, and if you haven't liked, subscribed and shared our page, you can like, subscribe and share our page. So without wasting time, we are going to start the next point, which is sign conventions, and it is very important while considering the ray diagrams or while solving the examples using some formulas regarding the lenses, or we had also considered the sign conventions in the last year, that means in the class 9, but those are regarding the mirrors. So similar type of sign conventions we are going to follow in the lenses also, that means same formulas or same type of sign conventions we are going to use in case of lenses also. So we are going to understand it with the help of diagram. So here I had shown both the lenses, convex as well as concave. So clearly in the first diagram you can see that the convex lens is shown, and in the second diagram I had shown the concave lens. Now here, if we consider the basic rule in case of sign conventions, so the basic sign convention is that while drawing the ray diagram, the incident ray is always shown from left to the right. That means its direction is always towards the right side. And here, if we see in both the cases, in concave or convex lens, you can see the direction of incident ray, which is shown exactly at the upside of concave lens as well as convex lens. So here we can see that the direction of incident ray is always shown from left to the right, whether it is convex lens or concave lens. So the first sign convention is satisfied. Then the next sign convention is that we have to measure the distances. That means object distance we have to measure, or sometimes we have to measure the image distance, or we have to measure the focal length. Here in case of lenses, 2 focal lengths are there, so we have to measure the 2 focal lengths. Then again we have to measure height of the object or height of the image, like this. So different quantities or different terms we have to measure, and in order to measure these values we have to follow one certain sign convention, and that sign convention is that all the distances should be measured from the origin, that means optical center O, either it is convex lens or it is concave lens. So whether you are taking convex lens or you are taking concave lens, in each and every case we have to measure all the distances from the optical center O. So we had studied that optical center O is the point through which all the lights are goes undeviated, all the incident rays are going undeviated, that means their directions are not changing. So from that point we have to measure all the distances, and that point is present inside the lens, whether it is convex or whether it is concave. Then whatever be the distance I am going to measure on the left hand side of the origin, that means of the optical center, so such distances are going to be taken as a negative. So distances which are measured on the left hand side of the origin, those are considered to be negative, whether I am measuring it for convex lens or I am measuring it for concave lens. So this is the first sign convention regarding the distances. Now we know that generally, not generally, always, we can use the word always we are keeping object to the left side, because we have to show the incident ray from the left to the right. So in order to incident ray should be travel in that particular direction, we have to keep the object to the left hand side. So that's why the object distance is always going to be negative according to our sign convention. Then in the same way, if I am going to measure the same distance on the right side of that origin O or optical center O, then such distances I am going to take as a positive. such distances should be taken as positive, whether I am considering the convex lens or concave lens. Then next sign convention is that if I am measuring the height of object or height of image, and I am measuring that height above the principal axis, height which is measured above the principal axis, then that height should be taken as positive. That height should be taken as positive. And if same height I am measuring below of the principal axis, then I am going to take it as a negative. So see the sign convention, when to take positive and when to take negative, and from where to measure the distances. So distances should be measured from optical center, that means origin, if you are measuring it to the left side, or height below the principal axis, then they are going to be negative. And if you are measuring the distance to the right side or height above the principal axis, then they are going to be positive. So these are the sign conventions which we have to follow while considering or while drawing the ray diagram of convex lens, or while solving the examples regarding convex lens or concave lenses. Now we have to consider some formulas regarding the lenses. So first formula is going to be lens formula. Now lens formula is nothing but it is one relation. You are familiar with the word relation. In the mathematics you had considered. Relation means we are relating the different terms, or we are relating the different quantities, like how they are depending on each other. That relation we have to consider. So here lens formula means it is nothing but it is the relation between three terms, and those three terms are distance of the object, that means u, then the distance of the image, that is v, and focal length f. So either you can take convex lens or concave lens. So the object distance, image distance, and focal length of the given lens we have to consider, and that relation is referred as a lens formula. So the relation between these three terms is going to be referred as a lens formula, and mathematically it is going to be denoted like this: 1 upon v minus 1 upon u, 1 upon v minus 1 upon u, which is equals to 1 upon f. And the second thing is that we have to also apply the sign conventions here before solving these values. After keeping the values, before solving we have to consider the sign conventions, whether that object distance is negative, or image distance is negative, or focal length is negative, or focal length is positive. So all the factors we have to consider. So this is the lens formula. Then the next formula is magnification. Now magnification means to increase the size of the image. Magnification means to increase the size of the image, and generally the convex lens is used to magnify the image. Generally convex lens is used to magnify the image, and that ability of the lens to magnify the image is referred as a magnification, capital M. And here if we consider the formula or definition for the magnification, then the magnification due to any lens is the ratio of, ratio means I have to take two terms, numerator and denominator. So ratio of height of the image, which is indicated by h2, to the height of the object, which is indicated by h1. So ratio, I have to take the ratio. So while taking the ratio, you have to consider the word TO2, and whatever with the portion is present to the left hand side of that word, that is our numerator, and the portion which is present on right hand side, that is our denominator. So here height of the image is going to be numerator. So therefore I can write down the formula for magnification as height of the image divided by height of the object. And if I will keep the symbols, then I can write the formula in mathematical form like M is equals to, capital M is equals to H2 upon H1, which is the required formula for magnification. Again, we have to consider the sign conventions also. If height is above the principal axis, it should be positive, and if height is below the principal axis, it is going to be negative. And the magnification due to the lens is also related to the distance of the object and that of the image from the lens. That means instead of heights, you can also take the distances of image or distances of object. So second formula we can generate for magnification: distance of image divided by distance of object. So we know that distance of image is indicated by V and distance of object is indicated by U. So therefore second formula for magnification is M is equals to V upon U. So you have to decide which factors are given. According to that, you have to decide the formula while solving the numerical examples. So this is the magnification formula. Then the next formula is power of the lens. Now here power of the lens means ability of the given lens to magnify the image. How much ability it has? It is easily magnifying, or it is has to take some efforts to magnify it, or it is magnifying rarely, like this. So whatever be the ability of lens to magnify the image, that is going to be referred as a power, and therefore we are going to refer it as the capacity of lens to converge or diverge incident rays is called its power. How easily that lens is converging or diverging the incident rays, that is going to be referred as a power. So it totally depends on focal length, and the power of a lens is totally depends on its focal length, and power is the inverse of its focal length. So how we are going to define it? Power is inverse of its focal length. Whose focal length? Focal length of that lens. Okay. So here we know that focal length is expressed in meters. So therefore the SI unit of power is referred as a diopter, which is indicated by capital D. So unit of power of the lens is diopter, capital D. So we can define it like this mathematically: P is equals to 1 upon F. P is equals to 1 upon F, and you can calculate the value of 1 diopter also. 1 upon 1 meter is the value of 1 diopter. And just remember, if the power is positive, then the lens is convex, and if the power is negative, then the lens is concave. So these are actually properties of convex and concave lenses. Same formula we have to follow, but if answer is coming positive, then the lens should be convex, and if answer is coming negative, then lens is going to be concave lens. Now we can also combine number of lenses. Like while forming the lens, we had combined two spherical surfaces. That means we had joined the two spherical surface with each other. So in the similar way, we can also able to combine some number of lenses, and after combining those lenses, we can calculate the effective focal length of the combination. So suppose if I am joining, or if I am combining two lenses whose focal lengths are f1 and f2, they are kept in contact with each other, so I am combining them. So the combination of these lenses gives the effective focal length by the formula 1 upon f is equals to 1 upon f1 plus 1 upon f2. That means you have to just add the focal lengths of individual lenses. So if instead of 2 lenses I am taking the 3 lenses, you have to add the term, you have to consider plus 1 upon f3. That means third focal length should be added to the first 2 focal lengths. So in this way we can increase that formula. That means if you are taking 10 lenses, then you have to take that formula according to that. 1 upon f1 plus 1 upon f2 plus 1 upon f3 dash dash up to 1 upon f10. So like this. So before using the formula, you should observe how many lenses we are combining. According to that, we have to take the formula. So these are some terms which or some formulas which we have to use while using the convex or concave lenses, like lens formula, then magnification, power of lens, combination of lenses, and then in order to solve these examples or in order to obtain these values correctly, we have to use the sign convention. So that also we had seen in the previous case. So this is it for today. In the next lecture, we are going to consider the next point from the same lesson. So here today we are going to stop here. So thanks for watching the video. I hope you enjoyed the video, and if you haven't watched the previous videos, you can access those videos from the links which are given in the description. And please, again I am going to request you that please like, subscribe and share our page, and also press the bell icon so you will get updates in the future regarding the lectures which I am going to post for the class 10 syllabus, or for the class 9, or for the class 8 syllabus, also for the class 12 syllabus. So again, thanks for watching the video. Have a nice day.